Alright, this video concludes or wraps up kind of the part that we started last time. I'm looking at the equations that are in the form a times x plus b is equal to c. So we showed one method in the last video that's using the distributive property first. So that's applying the distributive property, and then that gets you two separate terms, which then you can proceed just like we've done in previous videos. The second method, either work fine, is to, instead of doing the distributive property, try to either multiply or divide by that number that's out in front, and by doing so then you can eliminate it that way. So to show you that, we'll just do a couple examples. Okay, so the first one we've got here, 3 times d plus 0.4 is equal to negative 3. Okay, so this method then looks at this 3 in front, okay, and we recognize that that 3 is being multiplied by both the d and the plus 0.4. So our method 1, remember, would have used the distributive property to multiply that into each one. We're going to instead divide that 3 out. Okay, so the 3 was being multiplied by it. We are going to divide this entire side by 3. If we divide one side by 3, we better do the same to the other. By doing that, we go 3 divided by 3 is 1, which cancels off. Right? So we are left with d plus 0.4 is equal to negative 3.9 divided by 3, which is negative 1.3. Now we can proceed just like we normally would. Right? We see that d is being added to 0.4, or 0.4 is being added to d, and therefore we're going to subtract 0.4. What we do to one side, we got to do to the other as well. Okay, so 0.4 minus 0.4 cancels out. We're just left with d on the left side, and on the right side we've got negative 1.3 minus 0.4. That brings us to negative 1.7. Okay, let's try another one. Okay, this one, the computer version of it, or the typed up version of it, is maybe trickier to see. You might see it in your textbook written like this instead. Okay, and all this means is that we've got t minus 1 all being divided by 5. So before we would write that out and we would try to do a distributive property of the 1/5 that's out in front, but instead we are going to recognize t minus 1 is being divided by 5. Well, let's undo that operation by multiplying the whole thing by 5. We multiply one side by 5, we got to multiply the other side by 5. Okay, 5 over 5 cancels out. We're left with t minus 1. Over here we've got 3 halves times 5. Remember, that's multiplying fractions. You multiply the tops and the bottoms, so 3 times 5 is 15 over 2. Okay, we'll just move it up here for more room. Okay, we've got t minus 1 is equal to 15 over 2. Okay, t is, or negative 1 is, 1 is being subtracted from t, therefore we're going to add 1. Negative 1 plus 1 cancels out. We got to add 1 to this side. Okay, so we've got t on its own now is equal to 15 over 2 plus 1, or we could rewrite 1 as a 2 over 2. That's our common denominator there, so we write that as 17 over 2. We could leave it like that, or we could say convert it into a mixed number, and we'd have 8.5. Okay, one last example that I'll do, and then I'll leave one at the bottom for you to do, and we'll check that in class. Okay, so we'll do one more together here, recognizing that 2 is being multiplied by both e and the minus 0.6, so we're going to divide by 2. We divide one side by 2, we divide the other side by 2. 2's cancel. left with e minus 0.6 is equal to 4.2 divided by 2. Well, that is equal to 2.1. Okay, then we are going to, just like we've been doing, add the 0.6 to get rid of that negative, get e on its own, cancels out. Got to add 0.6 on this side, 2.1 plus 0.6 is 2.7. And you'll see as you do more and more of these, they get faster and faster. I'll leave one at the bottom for you to do, just to be clear what it's asking here. C plus 2 all divided by 3 is equal to negative 5 over 2. Okay, and I want you to solve for what C is. Okay, hope that method is helpful. You might choose to use that method instead of the distributed property one we did in the last video.